Okay, can you see the screen?
Yes, sir.
Okay, so what we discussed so far, right? Limit of function at a point. So, what is definition? Limit x tends to a, fx is equal to L if given epsilon there exists delta such that whenever distance of x from a is less than delta and x is not equal to a, then distance of fx from L is less than epsilon. So this is what we discussed last time. And if for every epsilon we are able to produce delta, then we say that L is a limit of function at a. So what is the negation of this statement? Right, so what is the negation of this definition of limit? Can you tell me what is the negation? Limit not equal to L. Limit x tends to a, fx is not equal to L. So limit is equal to L, then this above definition. So limit is not equal to L means what? How will you write down the negation?
If fx minus L is not less than epsilon.
Means what? For which epsilon?
If for a given epsilon there exists a delta greater than 0 such that 0 less than x minus a less than delta, but f of x minus L is greater than epsilon.
But what is a more appropriate way? So what is a limit x tends to a fx is equal to L if for every epsilon we can produce a delta such that for all x with right or alternatively for all x in deleted neighborhood of a for all x in deleted neighborhood of a we have fx is in epsilon neighborhood of L. Right, so this is in short or symbolically. Right, so limit x tends to a f of x is equal to L if for every epsilon there is a delta such that for every x in deleted neighborhood of a, f of x is in epsilon neighborhood of L. So for every epsilon this is going to happen. What is the negation? Not for every epsilon. Do you understand?
Yes, sir.
So if I give you a box containing fruits and I said that every fruit in the box is sweet, right? So what will be the negation of it? What will be negation of the statement? For each epsilon we can produce at least one delta. So what is the opposite? Suppose I give a box containing fruits and I say that every fruit is sweet. What is the negative of this when my statement is false?
That there is at least one fruit that is not sweet.
Yes. So now what is our statement? Limit is L if for every epsilon something happens. What is the negation?
There exists a epsilon for which this is not true.
Right. There is at least one epsilon for which the things fell. That means my statement is not true. So what I should write here now? if there exists some epsilon naught, a specific member epsilon naught for which there is no delta at all. What is our statement? For every epsilon we can produce delta. What is the negation? Not true. Means what? Not for every epsilon. That means for some epsilon the statement fails. Means for some epsilon we cannot produce delta. Right? So there exists delta. What is negation? There is no delta. Right? For this epsilon, there is a epsilon for which there is no delta. So means what? For this epsilon and for every delta, right? Or let me write it in words. So there is epsilon such that there is no delta, right? Such that for every delta, so there is epsilon for which no delta, means if you choose any delta, that delta fails. Means what? For every delta, whatever delta you select, the condition fails. Condition fails means what? There exists x in deleted neighborhood of A with the condition fails means f of x minus L is greater equal epsilon naught. Correct? Do you understand this?
Yes, sir.
Right. So logically, is it correct? Ki for every epsilon something happens means negation. For some epsilon there something fails. So what that thing fails? So what is the negation of that thing? So there exists delta. There is no delta. There is no delta means if you choose any delta, the things are things doesn't go nice. Means for if you choose any delta and a delta neighborhood around A, I can produce x whose distance from A is less than delta, right? That means x is in deleted delta neighborhood of A, but f of x minus L is not less than epsilon, right? So now using this is an exercise. Ki let f of x is equal to, for example, x, right? Prove that limit x tends to 0, f of x is not 1, right? So just apply the previous statement. Now the question is, uh, so is it possible that function can have more one two distinct limits or limits at a point, right? Is it possible that function can have more than one limits at a point? So it is similar to the sequences. What is the sequence limit of sequence? If limit of sequence xn exists, then it is unique. So if limit of sequence exists, then it is unique. Do you remember this?
Yes.
Yes, sir.
Right. That means when sequence tends to some number, it will tends to that number only. No way to go to some different. So is same thing true for limit of function. So uniqueness of limit. So let A subset of R, A belongs to R, F is defined from A to R, A is a cluster point of A, right? So these are the requirements to define limit, right? So domain of function is set A is some real number, but A is very close to A, so that we can approach A through the domain. Limit of function f at A is unique if it exists, right? So limit of function is unique at a point. If you are talking about limit at A, then it is unique if exists, otherwise it does not exist, right? If exists, then it is unique, right? If it is not unique, then we say that it does not exist, correct? Okay, so how to prove this? Suppose limit of f at A exists. Suppose it exists. So assume that f have two limits at A, say L1 and L2. That is, limit x tends to A, fx is equal to L1, and limit x tends to A, fx is equal to L2. So what is our claim now?
L1 is equal to L2.
Right, our claim is L1 must be equal to L2. Right, and so what is the strategy if you recall the proof for sequences? What should be the strategy?
So we need to prove that L1 minus L2 is equal to 0.
Huh, right. Suppose not, right? Suppose L1 is not equal to L2. Then we'll get contradiction, right?
Yes, sir.
So therefore, L1 minus L2 is certainly non-zero, right? L1 minus L2 is certainly non-zero. So now L1 minus L2 is non-zero means it might be positive, negative, we don't know, but it is non-zero if we assume L1 is not equal to L2. So let epsilon is equal to L1 minus L2 divided by 2, its absolute value. So is it positive quantity now?
Yes, sir.
Right, if two numbers are not equal, then their difference is may positive, may be negative, but if we take absolute value, it is certainly positive. So this is a positive quantity. Now, since limit x tends to A, fx is L1 by definition of limit. So what definition of limit says that for any epsilon we can produce delta for epsilon is equal to L1 minus L2 by 2. For any epsilon there is delta. In particular for this epsilon there exists delta. Let us call it as delta 1. Such that what type of delta 1 we get? Whenever distance of x from A is less than delta 1, then distance of fx and L1 is less than epsilon. Is this clear?
Yes, sir.
Similarly, limit x tends to a fx is L2. So similarly, limit x tends to a fx is L2. So again by definition for same epsilon, because when we say limit exists for any epsilon we can produce delta. In particular for same epsilon L1 minus L2 by 2, there exists delta, but this delta is different than previous delta, right? Because here L2 is a different number, so there is another number delta 2 such that whenever distance of x from A is less than delta 2, then distance of fx from L2 is less than epsilon. Right, now see the situation. What is the situation? So A, and suppose this distance is delta 1. So A minus delta 1, A plus delta 1. So this distance is delta 1. Now we found another delta which is delta 2, which may not be same as delta 1, right? And so it may be less than delta 1, may be greater than or equal to, so not an issue at all. So this distance is delta 2. So what is this point? A minus delta 2, and here this distance is delta 2, this is A plus delta 2. Now, what the statement, first statement says, what is the first statement? Let us call this as 1, this as 2. So, what first statement says, right? What first statement says, if x is in this range, a minus delta 1 to a plus delta 1, what happens?
The limit is L1.
No. If x is in a minus delta 1 to a plus delta 1, fx minus L1, the distance is less than epsilon, correct?
Yes, sir.
And what second statement says?
fx minus L2 is less than epsilon.
Right. Whenever distance x is in a minus delta 2 to a plus delta 2, right, this green color range. If x is in this range, green color, then fx minus L2 is less than epsilon. Now, can you tell me the range in which both things less than epsilon, fx minus L1 and fx minus L2, in which range both things are true?
Minimum
Delta
of
1.
delta 1 and delta 2.
Right, whichever is minimum in that range. So, let delta is equal to minimum of delta 1 and delta 2. In this figure, delta 1 is minimum, right? So then, if distance of x from is less than delta, then ultimately delta is less than or equal to delta 1 as well as delta 2. And therefore, when I say distance of x from a is less than delta, means distance of x from a less than delta 1 as well as delta 2. But if distance of x from a is less than delta, means it is less than delta 2. So fx minus L1, is it less than epsilon?
Yes, sir.
At the same time, can I say that fx minus L2 is also less than epsilon?
Yes, sir.
Okay, so let us call this as expression 3. Right. Therefore, for x in A with distance of x from A is less than delta, that is x belongs to A intersection V dash delta A, we have what is L1 minus L2. What is L1 minus L2? So I will add L1. So L1, I am looking at L1 minus L2 absolute value. I will add fx and subtract fx minus L2 as it is. So which fx I am adding? Do you understand what fx? Which number I am adding and subtract?
Yes, sir.
So I am adding and subtracting fx. But which x? Because fx is a real number, right? And what is that real number? The value of function at x. And which x? X which is in delta neighborhood of a. Those x I am concentrating on this a plus delta, a minus delta, and I am selecting some x in this range, and I am looking at f of x, and I am adding and subtracting that x, fx. Logically, everything is clear.
Yes, sir.
Right. Now by triangle inequality, right? Now,
Yes, sir.
so first term, is it less than epsilon?
Yes, sir.
Because my x is in the range a minor delta a plus, and so fx minus L1 is certainly less than epsilon. So it is 2 epsilon. But what is 2 epsilon? What is epsilon?
L1 minus L2 by 2.
Right. So ultimately, what we found. So hence, what the conclusion? L1 minus L2 is strictly less than L1 minus L2. So contradiction. Why contradiction? A number cannot be less than itself. Strictly less than itself is not possible, and hence so this gives us contradiction. And basically what leads us to the contradiction? Hence our assumption that L1 is not equal to L2 is not true, right? So what leads us to the contradiction? Right, what leads us to the contradiction?
L1 is equal to L2.
So we assume that L1 is not equal to L2. That is not true, because if you say L1 is not equal to L2, then that leads us to some contradictory thing. So this is not true. So here, therefore, L1 must be equal to L2. And so what is the moral of the story?
The limit at any point is unique.
Right. So thus limit of f is unique at a is unique if it exists. This is a immediate consequence of definition of limit, because otherwise if limit is not unique, then the things will collapse immediately, right? How things will collapse? So suppose you have launched some satellite, and you are expecting that your satellite will land to some place on Mars or Moon, whatever. Right? You have launched some satellite, and you are expecting that it will be landed at some place on Mars or Moon, and therefore as t tends to infinity, that means your time increases, the position of, right? So for t greater than 0, if we say that f of t is the position of satellite, right, at time t is equal to 1 hour, what is the position? That is the value of function at t. So I am defining a function. Do you understand? It is a function,
Yes, sir.
right? So if for some time t, f t is a position of satellite, now, and if this is your particular place m, alright, this is a place where you want to you expect that satellite will land at this place. This is your expectation according you, right? So scientists have made the calculations, and they expect the satellite will land at this place. So what we expect, it should land. So as t tends to, as t increases, right, and suppose you expect that it will land in suppose satellite will land at m in suppose 200 hours, right, and therefore as t tends to 200, f of t tends to what we expect, m. Do you understand?
Yes, sir.
Right, so this is application of limit because the scientists are using some programs, some softwares, and in that softwares the concept of limit is already used. Something is changed to something where then the object is tending, so that is already there. So suppose the limit is not unique, then what will happen? So do you understand?
So when time tends to 200, then position will tend to two different places.
Means there is uncertainty, right? There is uncertainty, and then it is useless, right? Because then if you are not sure ki the satellite will land at particular place, so you cannot do anything, right? Therefore uniqueness is there everywhere. Without uniqueness things will not be useful. In that sense it is necessary to have limit is unique. Now, so the point which I explained last time, ki why point should be a cluster point of a domain. So why point A should be a cluster point of domain of F while discussing its limit at A. So what property fails if a point is not a cluster point or it is isolated point? So let us consider simple example so that you can understand why the cluster point is very essential while talking about limit. Right? So let f is a function defined on, suppose I define a function. What is my domain here? A. Whatever is the set. Now I define function f of x is equal to x, whatever is. Actually the definition of function is also not uh, special at all. Anyway, that means what is f of 1 is 1, f2 is 2, f3 is 3, and so on. So this is my function. Fine. Okay. The question is, does limit of f at 1 exist? This is a very basic question. Even function is defined at 1. Is function defined at 1?
No.
No.
Yes, sir.
Why no? It is defined at 1 because 1 is in the domain. Yes?
Yes, sir.
Right, so it is defined at 1. But does limit at 1 exist?
No.
No, sir.
Suppose limit x tends to 1 fx exists. Suppose it exists. So suppose it exists, then what happens? Because what I in the beginning why I said that the cluster point is important, because if limit exists, what happens? So let limit x tends to 1 fx is equal to L. Suppose it is some number L for this function. Then by definition of limit, By definition of limit, what will happen? For given epsilon, there exists delta, right? Such that whenever then fx minus L is less than epsilon. Yes, is it correct whatever I am writing?
Yes, sir.
Fine.
Yes, sir.
Okay, so this is my point 1, 2, 3 and so on. This, so in domain there are only these many points. In domain there are only these many points, 4 and 5, nothing else. This is my domain, right? Outside this is not in the domain. Fine. Now what this previous sentence says ki if distance of x from 1 is less than delta, then distance of fx from L is less than epsilon. Fine. Now what is delta? Some delta, whatever it may. Suppose something is true in some bigger delta, right? If something is true in some bigger delta neighborhood of 1 plus delta, is it true in some smaller neighborhood? Is the same thing true in?
Yes, sir.
Right. Therefore, if I choose delta smaller, less than 1, so that means 1 minus delta, 1 plus delta. So, suppose, assume that delta is less than 1. Right. If it is bigger, then no problem, I will take smaller delta, which is less than 1. If something is true for bigger delta, then no doubt it is true for smaller delta, because when something is true in bigger set, it is true in smaller set. So that is my logic. So I will choose delta less than 1. There is no harm, there is no ambiguity, there is no violation of any rule, because whatever delta we have, if already delta is less than 1, fine. If it is bigger, then I will cut it down and I will choose smaller. No harm, right? If something is true for larger, so assume that delta is less than 1. Then 0 less than x minus 1 is less than delta, then fx minus L is less than epsilon. Fine. So last sentence is clear. Any ambiguity?
Yes, sir.
Fine. Now that means x belongs to deleted neighborhood of delta neighborhood of 1, then distance of fx from L is less than epsilon. Now you tell me what are the possible x in this delta neighborhood of 1, which are in the domain?
So if delta is greater than 1, then 2 is possible, 3
No,
is possible.
but what I am saying ki there is delta for every x in delta neighborhood, it is true. So if I cut it down and choose smaller delta, then also it must be true. Now I am necessarily taking delta less than 1. So what are the possible x which are in the domain and their distance from 1 is less than delta?
No x is
There is no
possible.
such X.
No x. Very good. So, okay. So if I choose delta less than 1 and if I choose x is in delta neighborhood of 1, then f of x minus L is less than epsilon. Can I say that f of x minus 100 is less than epsilon if x is in this neighborhood of 1? Can I say this?
No, sir, because X does not belong to both.
X belongs to V delta dash 1 intersection A, then f of x minus 100 is less than epsilon. Is this statement true or false?
False.
Why false? Give me counter example for which it fails. What is my statement? What is my statement? Ki every student from in A division is from Mumbai. This is my statement. When my statement will fail,
If we
Sir, it is
produce
a
at
true
least
state.
one student, if
right? If you can show me a student from A division who is not from Mumbai. So what my statement, every x in this delta neighborhood satisfy this condition. When this statement fails,
So if
When the
there is
first
at least
statement is
one.
true and second statement is false.
so my statement is every x in this delta neighborhood of 1 and it is also in A, every such x, for every such x, f of x minus 100 is less than epsilon is fails if you can produce x in this set for which this fails. Can you produce such x?
No, sir.
There is no such x, so you have to accept my statement. You cannot counter my statement. If there is no counter to my statement, you have to accept. Right? So universe is infinite. Nobody has proved that the universe is not infinite. So we are accepting it. It doesn't mean that it is true, because there is no counter argument to that. Can you give me counter argument to this?
No, sir.
No, sir.
Right. And therefore you have to accept that fx minus 100 is less than epsilon, because you cannot produce x for which it fails. Can I say that fx minus 5000 is less than epsilon whenever x is in this neighborhood?
Yes, sir.
Yes, sir.
Okay, now what is the problem?
There are infinite limits of
Ah,
x.
every number is a limit, because you give me epsilon, I can give you delta less than 1, and if x is in that delta neighborhood, f of x minus that number is less than epsilon, no doubt. So what happened? So uniqueness fails. So what above argument says? What above argument says? Yes, every real number is a limit of functions. This suggests that every real number is a limit of f at 1. Contradiction. Contradiction to what?
Uniqueness of limit.
Uniqueness of limit. Right, at same point 1 you can have many limits, so that fails. And what is the moral of the story? What is the moral of the story? And what type of point we were talking about? 1. And is 1 cluster point of set A?
No, sir.
no,
No, sir.
no.
So therefore, when we talk about, so what is moral of the story? A point should be a cluster point. Right, at isolated point limit does not exist. Right, and here whatever is the definition of function, that doesn't matter. Either you take f of x is equal to x, or f of x equal to x square, or f of x equal to sin x. Whatever is your definition of function doesn't matter. If point is isolated, limit does not exist. So do you understand why cluster point is very essential?
Yes, sir.
Right. Okay, now let us go ahead. If this idea is clear, so algebra of limit. So likely similar to the sequences, right? So suppose E is subset of R, A is in R, f and g are two functions defined on A. A is a cluster point of A. So when I say A is a cluster point, what are the possibilities? Do you understand? When I say
It may or may not belong to a domain.
right, A belongs to A or A is not member of A. There are two possibilities when I say cluster point. So suppose let limit x tends to A if x is equal to L1 and limit x tends to A gx. Right, so domain of f and g is same. F and g are defined on same domain. So L2. Right, suppose limit exists. Limit of f and g exists. Then so limit x tends to A. What is fx plus gx? What is the limit of sum of two functions? And what we expect?
L1 plus L2.
Right, because as we discussed last time, the sequences gives us some idea about the limit, right? Do you understand that?
Yes, sir.
And have you tried the exercise that I have already shared with you in PDF form?
Yes, sir.
So the sequence gives us idea about the limit at a point. So and therefore, if you looking at fx plus gx, then look at the sequential criteria fxn plus gxn, and we know limit of sum of two sequences. So here we can expect key limit should be L1 plus L2. What about minus? Right? So what does it mean? Limit of fx plus gx is L1 plus L2. But what is L1? Limit of fx. What is L2?
Limit of gx.
Gx. And therefore sum of limit is limit of sum is sum of limits, right? And the limit of difference is difference of limits. This is similar to the sequences. So if alpha is a real number, then limit x tends to A alpha times f. This is a new function, right? If you multiply by alpha, this is new function. And what we expect here? That means alpha times limit of fx. Now third, limit x tends to A fx into gx, so product. And what we expect here? L1 into L2. See, here we expect the limit of product is product element because of sequential approach. If you see the sequences and the product converges to product, the sequences plays a very important role in this analysis. So limit x tends to a fx into limit x tends to a gx. Fourth, okay, what should be fourth? What should be the fourth one?
Division.
Division. But there is a problem. What will happen? To divide, the thing should be nice, right? Means what? If L2 is 0, how can you divide? But if function is like this, function is non-zero, but limit at a is 0, right? If this is my function g and at a as x tends to a, f of x tends to 0, you cannot divide even though function is non-zero. If g is non-zero, fx upon gx makes sense, right? Fx upon gx makes sense because gx is non-zero but limit is 0. Limit of g is 0, so that is possible, right? Now if L2 is non-zero, L2 is non-zero means what? Then can you divide? Can you look at the question?
Yes, sir.
Okay, but what is the guarantee that, because while dividing, so x approaches say fx upon gx is L1 upon L2. So L1 upon L2, L2 is non-zero, so L1 upon L2, no problem. But what about gx? If gx is 0, then what will happen? Because x is not a, right? So x is somewhere here and x approaches a. At this place, it may happen that g is 0. How can you divide now? Right, so there is a dilemma.
So gx should also be non-zero.
Shall we put this condition?
Yes, sir.
Okay. So before proving this theorem, we'll see a lemma. What is the mean by a lemma? Lemma is a result or statement which is useful to prove some big theorem. So what is a lemma? Let a subset of R is in R is be a cluster point of A. F is a function defined on A. Suppose limit x tends to A, fx is L. Right? So if L is non-zero, then because we are worried if limit is non-zero, we don't know about function, right? Function may be 0, may not be 0, but limit is non-zero at A. This is a key point. Then what will happen? Will happen. Now imagine a very simple situation. Suppose some particle is moving like this. Particle is moving to some t naught. As time goes to t, as t tends to t naught, then particle moves and it settle at this point. Particles settle at t, or as t tends to t naught, the particle tends to L and L is positive. Now observe this situation, what happens? Can you see the figure?
Yes, sir.
Okay, now see the figure and what happens. And just imagine the real life situation. Some particle tends to time t naught, then its position tends to L. Or some butterfly is flying like this, and as time goes to t naught or some particular value t naught, then its position tends to some position L, and that position is positive or above x-axis, right? Can you say that before reaching to t naught, for some time it is in the positive region?
Yes, sir.
Right, before reaching to t naught, right, for few seconds or for some time before t naught, it is already on positive side. Yes.
Yes, sir.
Okay, so mathematically how to say this? If L is not 0, then there exists delta. There is a neighborhood of t naught. In that neighborhood, it is already on positive side throughout. Yes, such that f of x is non-zero for all x in what? In this neighborhood. Do you understand the statement now?
Yes, sir.
Yes, sir.
Right. So, if I am talking at a and I am saying that limit at a is positive, so whatever is my function, then there is a neighborhood a minus delta to a plus delta. In that neighborhood already function is positive. Right, if non-zero, either positive or negative. Our situation may be like this: at a, the value of function is limit at a is negative. So limit at a is negative, that means there is a neighborhood. In that neighborhood already function is negative, right, for some range. A is not, a may not be member, so we cannot say anything about at a, but near a, what we are sure, near a, in the neighborhood of a. At a, that we are not sure, because function is may not be defined at a. So intuitively we can observe this and we understand, okay, this happens, but we should have a concrete proof. As a mathematics student, just observations are not sufficient, right? Observations may misguide us, so we should have a concrete proof. So what is a proof? Okay, so assume that L is non-zero, then what should be my next sentence? What should be my next sentence? L is non-zero means what? Then either yes,
Yes, sir.
either L is positive
Yes,
or
sir.
negative. If positive, case 1, suppose L is positive. L is positive. Therefore, L by 2 is positive. Now, from this figure, can you tell me the strategy? What is our claim?
We'll take epsilon as L by 2, mod of L by 2.
So what is our claim? There exists delta such that for all x in V delta dash of A, f of x is positive. If limit is positive in some neighborhood, function is positive. Do you understand? If limit at a is positive in some neighborhood, function is positive.
Yes, sir.
Okay, so how to do this? So we are assuming L is positive, so L by 2 is positive. So since limit x tends to a fx is equal to L for every epsilon we can produce delta. In particular, for epsilon is equal to L by 2, there exists delta such that whenever distance of x from C is less than x from A is less than delta, then distance of fx from L is less than L by 2, which is our epsilon in this case. That means whenever x belongs to a minor delta to a plus delta, right? If x is in a minor delta to a plus delta and x is not equal to a, then eliminate this absolute value sign. So minus L by 2 less than fx minus L is less than L by 2. So whenever x is in this neighborhood and x is not equal to a, then L minus L by 2 less than fx is less than L by 2 plus L. So, right, is it correct?
Yes, sir.
Okay,
Yes,
so
sir.
now what does it mean? What does it mean? L by 2 less than fx is less than 3L by 2. Right? Is it correct?
Yes.
So, means what? Ultimately, what we get, therefore,
F of x is positive.
so and already L is positive, so L by 2 is positive, right? So from this, can I say that if x is in deleted neighborhood of A, right? So if x is in deleted neighborhood of A, then can I say that f of x is positive? In fact, it is greater than L by 2, right?
Yes, sir.
Right. So are we able to produce a delta neighborhood?
Yes, sir.
Fine. And so is the conclusion true? That means there is a delta such that for all x in deleted neighborhood of A, f of x is positive. Similarly, what is the second case? What is the second case? L is negative. If L is positive, limit is positive, there is a neighborhood in which function is positive. If L is negative, what should what we should claim here? What is claim here? What is the claim?
There exists a delta for which f of x is negative.
Right. So for all x is in V delta dash A, f of x is negative. So and you work out this remaining part. It is similar to this, right? So can you do this?
Yes, sir.
Okay, so tomorrow we'll see more about limits and some more interesting results. Right. Yes, any doubts?